We've all been there, right? Stuck in bumper-to-bumper traffic, staring at a red light, thinking there has to be a smarter way. Well, for decades, trying to manage the flow of a city has been this incredibly stubborn problem. Today, we're going to talk about a huge breakthrough that completely reframes the issue. It's about using generative AI not just to predict traffic, but to actually reason about it.
And it all really boils down to this one simple idea. For so long, we've treated traffic like a math problem that could be solved with the right equations and rigid models. But that, it turns out, was the fundamental mistake. Why? Because traffic, it isn't clean. It isn't predictable.
Okay, that sounds super technical, but what does it really mean? Well, think about it. The conditions on the road are always changing. That's the non-stationary part. One accident, a sudden rainstorm, a big game getting out, and the whole system is different. Then you have thousands of individual drivers, the multi-agent part, all making their own choices, some rational, some not so much. And on top of all that, we never have a perfect godlike view of every single car. It's partially observable. You see? You just can't plug a system that messy into a simple formula and expect it to work.
So, to really get why this new approach is such a game changer, we have to look at why everything we've tried before just fell flat. We're talking about those old-school simulation-based models that have been running in the background of our cities for years.
And this slide right here, this is where it all falls apart. The old models were built on a fantasy. They assumed traffic was stable, that drivers were all perfectly logical robots who followed the rules to the letter. But what's the reality? Demand is spiky and unpredictable. We drivers are adaptive. We're irrational. We change our minds. We negotiate space with each other on the fly. These models were designed for a world that literally does not exist.
And because of that fantasy, these systems fail in three critical ways. First, they need constant babysitting. An engineer has to manually retune them every time something changes. Second, they can't learn. They make the same mistakes over and over because there's no feedback loop. But here's the biggest problem, the real kicker. Even a perfect prediction is not the same as a smart decision. The model might tell you, hey, a huge traffic jam's about to happen on Main Street. Great. So, what do we do about it? The model has no answer.
All right, so that brings us into the modern age. We've got machine learning, which is a massive leap forward, because ML is incredible at one very specific thing, prediction.
And this is the question everyone asks, right? If our new AI can predict traffic with, say, 95% accuracy, isn't that it? Problem solved? Well, as it turns out, prediction is only half the battle. It's not even the hardest half.
This chart really lays it out. A machine learning model gives you a forecast, but it doesn't know how to act on it. It's like a weather report that tells you a hurricane is coming but offers no evacuation plan. It's also usually trained on a single goal, like move cars faster, when a real city has dozens of goals, like keeping pedestrians safe, or making sure buses run on time, or giving emergency vehicles a clear path. And crucially, it doesn't understand constraints. It might suggest a solution that's completely unsafe or illegal because it can't reason about rules.
And this is where the entire paradigm shifts. We've realized the missing piece wasn't a better crystal ball. It wasn't about getting a slightly more accurate prediction. The missing piece was an entirely new layer, a layer built for decision-making.
So what does a real traffic system need? Well, it needs to think like an operator. It needs to satisfy hard constraints, things like never ever block the fire station. It needs to make intelligent trade-offs, like, is it better to delay these 50 cars by 1 minute to let a bus with 80 people get through on time? And it has to do temporal planning. It needs to think ahead to understand how changing this one light now will impact the whole network 10 minutes from now. See, this isn't a prediction problem anymore. This is a reasoning problem.
So let me be really clear about this, because it's the most important point. We don't use GenAI to predict the traffic. We still use machine learning for that. We use GenAI to reason on top of those predictions. It looks at all the possible futures and evaluates different plans. It thinks about the consequences. It respects the hard rules. And, this is huge, it can actually explain why it made the choice it did.
Okay, so that's the theory. But how does this actually work in a real-world production system? Let's pop the hood and walk through the architecture step by step.
So first things first, it all starts with data. You have a constant fire hose of information coming in from all the city's sensors, CCTV cameras, radar, those little loops in the pavement. That raw data gets collected and cleaned up right at the source.
Next, all that clean data gets fed into the prediction engine. Now this is where our traditional machine learning models live. They're churning through the data, doing what they do best, forecasting what's likely to happen next. How long will the queue at this light get?
What's the chance of an accident at that intersection? This gives us our crystal ball, our view of the possible futures.
And here it is. This is the magic. Those predictions, those possible futures, they all get passed to the GenAI decision intelligence layer. This is the brain of the operation. It takes the what might happen from the ML models and asks the really hard question. Okay, so what's the smartest thing to do about it? It plays out dozens of scenarios, weighs the pros and cons, and formulates an actual plan of action that respects all the city's goals and rules. It's reasoning, not just reacting.
And finally, that plan doesn't just go straight to the street. It passes through a final safety check, just to be absolutely sure, before it's executed, changing traffic light timings, updating messages on digital signs. But crucially, the story doesn't end there. The system watches to see what happens next. Did the plan work? That result gets fed right back into the system, creating this constant loop of action, outcome, and learning. It gets smarter every single day.
And this is what a decision from the AI actually looks like. It's not some black box command. It's clear. It says what to do, extend the green light. It says why, to prevent traffic from backing up onto the freeway. And it even gives a confidence score. This makes the entire system transparent and accountable. A human operator can look at this and understand the AI's logic instantly.
All right, so let's zoom out and put all the pieces together. Let's look at why this complete architecture isn't just a small improvement, but a fundamental shift in how we manage complex, real-world operations.
I mean, this slide says it all, doesn't it? Traditional machine learning is powerful, but it can't reason about rules, and it can't explain its choices. GenAI can. It builds on the raw predictive power of ML, but it adds that missing, critical layer of reasoning, of explainability, and of strategic thinking. It's the piece that finally closes the loop.
And that brings us to the final, most important takeaway. We are moving away from building passive tools that just simulate the world to building active, intelligent agents that can actually operate in the world. This is not some academic model running on a server somewhere. This is a real-time operational brain for a city's infrastructure.
Which leaves us with a pretty mind-bending thought to end on. Traffic, as complex as it is just one kind of dynamic system. If this architecture, this combination of prediction and reasoning, can orchestrate the arteries of a city, what comes next? Power grids? Global supply chains? Airport logistics? The potential here to build truly intelligent systems that can manage the complex world around us is just extraordinary. Thanks so much for watching.